All right, let's go ahead and talk about one-dimensional force problems. In the 2025 school year, this is page 13 in your packet. It might be a different page in your packet um, currently, but just find where this problem is. It should be around page 13. So to solve your 1D force problems, you start with these 4 steps. So your first step is always going to be drawing a free body diagram. This helps you really figure out what forces are present, what's going on there. So in this situation here, for our first step, we have this 0.75 kilogram model rocket moving straight up with an acceleration of 1.5 meters per second squared. What's the applied force from the rocket's engine if we're ignoring air resistance? So if we're ignoring air resistance, when we draw our free body diagram here, we're going to have that force straight up, that applied force, Fa. And then we're also going to have that force down from our force of gravity. Now, our force of gravity is going to be smaller than our applied force. We don't necessarily know how much smaller. However, we do want to make sure it's very clear in our free body diagram that we know that applied force is larger, which is why my arrow is so much dramatically longer here. We're moving straight up, so that's going to be a positive velocity arrow. And then my acceleration is going to be positive as well because that engine is on, making us accelerate upward. So our next step is to determine our x forces and y forces. Well, there's nothing happening in my x direction, so I'm going to go ahead and say that my x forces aren't necessary here. So I have 2 forces in my y direction. I have my applied force, which is what I'm asked to find, so that's my question mark. And then I also have my force of gravity here. And I know that force of gravity is always equal to mass multiplied by the acceleration of gravity. So I know my mass is 0.75 kilograms multiplied by my negative 9.8 meters per second squared. And I'm going to get negative 7.35 newtons here. So next I'm going to go ahead and start to build my equation. So I know this object is accelerating because I'm actually given an acceleration here. So when I build my equation, net force equals ma, I'm only going to look at those y forces because I don't have any forces in the x direction. And this is going to be equal to mass times acceleration because I am accelerating. So this net force here essentially means total force, or the sum of all of our forces. So the sum of our forces is going to be our applied force plus our force of gravity. And that's equal to our mass times acceleration. We're going to go ahead and plug in what we know. So I know my force of gravity is this negative 7.35. Here's where we're going to take a pause, and we're going to make sure that the sign of what we plugged in here matches the direction on our free body diagram. So here I plugged in a negative, which would indicate going down or right, and my arrow on my free body diagram is pointing downward. So that means I'm in good shape here. Then I'm going to go ahead and plug in for my mass, and then my acceleration is going to be that positive 1.5. Then my only unknown is my applied force, so I can go ahead and solve for it algebraically here. 0.75 times 1.5 is 1.125. I will add 7.35 on both sides. And when we add those together and we round, we come to that 8.48 newtons. So there's my applied force. Let's go ahead and try another one. So we have a person in an elevator. So these elevator problems are going to be pretty unique because a person in an elevator actually acts differently, or you see different forces than you would see on an elevator. If we were looking at the elevator itself, that upward force would be tension, but here we're looking at the person. So that upward force, sorry about that, is going to be that normal force pushing up on them from the floor. They're moving upward and slowing down. So my velocity arrow is going to be positive. However, my acceleration arrow is going to be negative because to slow down, velocity and acceleration need to be opposite directions. So what that's telling me is my larger force, or my total force, needs to point downward, meaning my force of gravity is going to be longer than my normal force. Again, in this situation, I don't have any forces in the left-right direction, so I'll cross that out. And then in my y direction, I don't know my normal force. That's my question mark. But I can find my force of gravity using mg. My mass is 55 kilograms. My acceleration of gravity is negative 9.8 meters per second squared. And I end up with negative 539 newtons. Now I'm going to go ahead. I'm going to set up my net force equation. We are accelerating, so this will be equal to ma. This will be normal force plus force of gravity equals that mass times acceleration. When I go to plug in here, my normal force, we don't know it. My force of gravity is negative 539. I check. Okay, that force is negative. My arrow's pointing down. Good. I plug in my mass. And then, since my acceleration arrow is pointing downward, that means the value I plug in for acceleration should also be negative. So that should be a negative 0.25. It's very important that you're careful about this. When I go ahead and simplify this and solve, this side ends up being negative 13.75. I'll add 539 to both sides. And when we round to the nearest whole number, we will end up with that 525 newtons. So go ahead, try the rest of these problems on your own. Those answers are given to you at the bottom. And then you're going to see in this next question, you see that small difference. We're speeding up instead. So how does that change the sign of your acceleration? How does that change the length of your normal force arrow? So good luck. If you have any questions, write them down, ask your teacher. Thanks for watching, you guys.